ChatGPT has started a very intense conversation.
He thinks it's the most revolutionary thing since the iPhone.
Venture capital interest in AI startups has skyrocketed.
All of us working in this field have been optimistic that at some point the broader world would understand the importance of this technology. And it's actually really exciting that that's starting to happen.
Every company makes mistakes, and I make a lot of them. And some of them puts the company in peril, especially in the beginning. I delivered the first one of these inside an AI supercomputer to OpenAI when it was first created.
Nvidia's new AI chip is shaking up the tech world, smashing through the limits we thought were set in stone. This isn't just progress, it's a revolution that challenges everything we know about technology. Everyone's talking about Nvidia's Hopper architecture. It's a game changer. What if this breakthrough means that all other computers are now obsolete? Let's dive into the impact of this cutting-edge technology and explore how it could redefine the future of computing. Nvidia's breakthrough in AI innovation. This new AI chip is truly groundbreaking, challenging the very basics of physics. Only 4 companies in the world have reached this level of achievement: Microsoft, Apple, Google, and Nvidia. Based in California, Nvidia has seen its market value soar from $1 trillion to $2 trillion in just 8 months. This incredible growth is fueled by the high demand for its advanced technology, which is driving today's AI revolution. It's amazing to think that a company that started in 1993 to improve video game graphics has become a major player in AI in the 21st century. In March 2022, Nvidia introduced the Hopper architecture, designed specifically for data centers to power AI accelerators. The release of Hopper created a lot of excitement in the AI community, leading to high demand. But that's not the most surprising part. During the AI boom of 2023, prices for these products skyrocketed due to shortages and overwhelming demand. Customers had to wait 36 to 52 weeks to receive their H100-based servers after placing orders. Despite this, Nvidia managed to sell an astounding 500,000 H100 accelerators in just the third quarter of 2023 alone. Nvidia's dominance in the AI market and the success of its Hopper products played a key role in boosting the company's market value. Moving forward, Nvidia introduced the Blackwell architecture, named after the respected American mathematician David Blackwell. His groundbreaking work in game theory, probability theory, information theory, and statistics has greatly influenced the design and training algorithms of AI models based on transformers. Blackwell was also the first African-American scholar inducted into the National Academy of Sciences. In October 2023, during an investor presentation, Nvidia revealed its updated data center roadmap, which now includes the B100 and B40 accelerators alongside the new Blackwell architecture. This marked a shift from the previous reference to Hopper's successor as simply Hopper Next in roadmaps. Then at the Graphic Technology Conference, GTC, on March 18, 2024, Nvidia officially unveiled the Blackwell architecture. Over 11,000 enthusiasts, including software developers, tech leaders, and excited shareholders, gathered at the Pro Hockey Arena in San Jose for a 4-day AI event. All eyes were on one man, Jensen Huang, the CEO of Nvidia. But there's more to this story. Huang explained that Blackwell is not just a chip, it's a complete platform. While Nvidia is commonly associated with GPUs, they've pushed beyond the usual designs with Blackwell. Hopper, which represents the height of GPU advancements today, is at the core of this. It features an impressive 28 billion transistors, but what really makes it special is its architecture. For the first time, Nvidia combined 2 dies into a single chip that communicates at an astounding speed of 10 terabytes per second. It doesn't suffer from memory or cache issues. It performs like one giant chip. When doubts arose about the ambitious goals for Blackwell, Nvidia stayed the course. And the result was this innovative chip that fits seamlessly into 2 types of systems. One system aligns perfectly with Hopper, making upgrades simple, while the other, shown on a prototype board, showcases its incredible power and future potential. Imagine a setup with 2 Blackwell chips and 4 Blackwell arrays connected to a Grace CPU through ultra-fast connections, a system ready to revolutionize computing. According to Huang, what's truly remarkable about this computer is that it's the first of its kind, packing an incredible amount of computing power into such a small space. However, to push the limits even further, Nvidia needed a series of new features that could challenge the boundaries of physics. This is where Nvidia's latest invention, the 5th generation NVLink inside the new Transformer engine, comes into play. This engine is twice as fast as its predecessor, Hopper, and includes computing capabilities within the network itself. Why is this important? When multiple GPUs work together, they need to share and sync information. Let's see how Nvidia is changing the game with its latest technology. Powering Nvidia's generative AI supercomputer. Having ultra-fast connections and the ability to process data directly within the network greatly improves performance. Although it's rated at 1.8 terabytes per second, its actual speed is even higher, making it much faster than the Hopper model. This chip offers 2.5 times better training performance per chip compared to Hopper, thanks to its new FP6 format. It also introduces FP4, which doubles the speed for tasks that require quick decisions, like inference. This is crucial for saving energy, reducing network load, and making better use of time, all of which will be incredibly important as generative AI continues to grow. Nvidia is calling this new phase generative AI because it represents a significant change in how technology works. The new Nvidia processor is specifically designed for this era, with a key feature being its ability to generate content using the FP4 format. This chip, which is part of the Nvidia Blackwell AI supercomputer, can produce 5 times more data and decisions than Hopper. But that's not the end of the story. Nvidia isn't stopping there. They're working on creating an even bigger and more powerful GPU, surpassing what's currently available. Enter the NVLink switch, a groundbreaking chip with 50 billion transistors, almost as large as Hopper itself. With 4 NVLinks, each running at 1.8 terabytes per second, this chip lets all GPUs communicate at top speed simultaneously. This is a revolutionary step forward, pushing the boundaries of what's possible in computing. A system like this represents a major upgrade from what existed just 6 years ago. Back then, the first DGX-1 had a relatively small 170 teraflops, or 0.17 petaflops. Fast forward to today, and Nvidia is aiming for 720 petaflops, nearly reaching the exaflop milestone for training. This is a massive achievement. It's the world's first exaflop machine, all packed into a single unit. To give you some perspective, there are only a few exaflop machines in the world right now. This DGX isn't just another AI system, it's a powerhouse condensed into a sleek rack. But how is this possible? The secret lies in the NVLink backbone, which has an incredible bandwidth of 130 terabytes per second. To put that into perspective, it's faster than the combined speed of the entire internet. And what's more, this is accomplished without the need for expensive optics or transceivers, saving a significant amount of energy, specifically 20 kilowatts in a rack that uses 120 kilowatts in total, keeping a comfortable temperature of 25 Celsius while it runs. The air conditioning system helps a cooling setup. The water that comes out is like the warmth of a hot tub at 45 Celsius, flowing steadily at 2 liters per second. This ensures the system cools down efficiently without any problems. Now let's turn our attention to the key part of this setup, the GPU. While many might see a GPU as just another component, for Nvidia it represents much more. The old days of bulky GPUs are gone. Today's GPUs are complex pieces of technology made up of an impressive 600,000 parts and weighing a massive 3,000 pounds. To put that into perspective, that's the same as 1.5 tons, which is truly remarkable. Think about the task of training a GPT model with 1.8 trillion parameters. In the past, this would have taken 3 to 5 months using 25,000 amps of power. But with the Hopper architecture, this process now only needs around 8,000 GPUs and uses up 15 megawatts of energy, getting the job done in about 90 days. However, with the newer Blackwell architecture, the same task can be completed with just 2,000 GPUs and only 4 megawatts of power, showcasing a significant improvement in both efficiency and performance. Now explore how Nvidia's new tech is shaking up whole industries. The frontier of robotics innovation. At the core of the Groot project is Isaac Lab, a special tool created by Nvidia for teaching robots. Using Omniverse Isaac Sim for simulations, Isaac Lab gives robots a virtual space to practice and get better at handling different real-world situations. Working alongside Isaac Lab, but here's where it gets even more exciting. Blackwell is set to be Nvidia's most successful product launch yet. As we enter the world of Nvidia robotics, it's clear that this technology is about to make a huge impact. Nvidia is now stepping into the fascinating world of physical AI, where machines interact with the real world around them. Up until now, AI has mostly been limited to the digital realm, working within the confines of a single computer like the DGX system. But imagine a future where AI breaks free of these limits, where robots have their own intelligence and can navigate real-world environments on their own. This is where the magic of what Nvidia calls the robotics ChatGPT moment happens. Nvidia has been hard at work developing complete systems for robotics, including AI training from DGX and AGX, the world's first robotic processor, designed to process high-speed sensor data in energy-efficient environments. The Omniverse, Nvidia's tool for creating virtual worlds hosted on Azure Cloud, connects the digital and physical worlds. Picture a fully autonomous warehouse filled with activity, where people and forklifts move smoothly under the guidance of the warehouse, acting like an air traffic controller. This intelligent system keeps everyone safe by managing traffic and providing instructions throughout the warehouse. And the best part? You can even interact with this advanced warehouse in real time. Each robot has its own autonomous robotic system, making the entire operation efficient and seamless. With Blackwell leading the charge, the future of robotics is within our reach. But this isn't where the story ends. Let's dive even deeper into the wonders of robotics. The future of humanoid robotics is just around the corner, and soon robotics will dominate various industries because it's a safer and more convenient option. The automotive sector in particular is about to see a major transformation. Next year, Nvidia will work with Mercedes and later with JLR to integrate its state-of-the-art technology. Huang announced that BYD, the world's largest electric vehicle company, will adopt Nvidia's latest innovation, Thor. This next-generation computer, designed for advanced engines, will power the future of robotics and might even lead to the creation of humanoid robots. This is a groundbreaking step as Nvidia launches the project, pushing the boundaries of humanoid robotics. Nvidia's Groot project is an exciting initiative that aims to change the way robots learn and interact with the world. Nvidia is venturing beyond just imagining new possibilities. They're actually inventing and discovering ways to push the limits of what humanoid robots can do. The Groot project is a big step forward in robotics, offering a detailed model that can handle complex instructions and learn from past experiences. This model, equipped with advanced algorithms, helps robots decide their next actions on their own, making the link between human commands and robot actions much smoother. Is Osmo, a new service that helps coordinate training and simulations, making sure everything runs efficiently on Nvidia's powerful DGX and OVX systems. One impressive feature of the Groot project is its ability to learn from just a few human demonstrations. By observing a few examples, robots equipped with Groot can assist with daily tasks and copy human movements with impressive accuracy. This is thanks to Nvidia's advanced technology, which uses sophisticated neural networks to understand human behavior and turn it into practical actions for robots. Next, discover how Nvidia's innovations bring robots to life. Pioneering robotics with natural language capabilities. But that's not all. The Groot project also allows robots to follow natural language instructions, making them even more flexible and easy to use. Whether it's something simple like a pat on the back or something more complex, robots powered by Groot show an incredible level of intelligence and adaptability. This is all made possible by Nvidia's new Jetson Thor robotic chips, which are specifically designed to provide the power needed for these advanced robots. But here's the kicker. This isn't just about cool new features. The Groot project is leading the way in robotics, opening up possibilities for a future where robots could be a part of our everyday lives, changing industries and how we interact with technology. Nvidia's commitment to excellence and cutting-edge technology ensures that the future of humanoid robots is bright and full of potential. Now let's take a moment to appreciate how Nvidia got to where it is today. Back in the 1990s, when TVs were fuzzy and the internet was slow, computers were starting to become a big deal. But the graphics were simple, just text and basic images, unless you were doing something special like animation or engineering. For better graphics, people turned to video game consoles. But three engineers from California, Jensen Huang, Chris Malachowski, and Curtis Preem, had a different idea. They imagined a separate chip that could handle complex graphics for personal computers. After many late-night brainstorming sessions at a local Denny's, they realized that while CPUs were good at handling one task at a time, creating 3D graphics for games required handling many tasks at once. Their solution was a new type of chip that could do multiple tasks simultaneously, a breakthrough that changed computing forever. Boosting efficiency for tasks like 3D graphic rendering, a new type of chip, later known as the GPU, was created. This chip wasn't meant to replace the CPU, but to work alongside it, specifically for graphic tasks. This idea laid the groundwork for Nvidia, a company that would go on to change not only computing, but also the field of computer science over the next 20 years. However, back in the early days, Nvidia's main focus was on improving PC gaming experiences, a market with a lot of potential. In 1993, Nvidia's empire began in a small condo in Fremont, California. The company was built on the idea of integrating parallel processing GPUs into home computers. The name Nvidia comes from a combination of NV, which stands for next version, and Nvidia, which is Latin for envy. The green color in their logo was chosen to symbolize the envy they hoped their powerful chips would inspire. Nvidia was founded by three top engineers. Jensen Huang, a Taiwanese-American electrical engineer, had a wealth of experience as the director of coreware at LSI Logic and as a microprocessor designer at AMD. Chris Malachowski brought valuable engineering experience from HP and Sun Microsystems, and Curtis Preem was a former graphic chip designer at IBM and Sun Microsystems. Although they were all skilled engineers, starting a new company presented its own set of challenges. In 1993, the founders found themselves at a crossroads, unsure of how to move forward. They hired a lawyer to help with the legal process of setting up the company. With just $200 to his name, Huang made a bold decision to invest his own money to get Nvidia started. This small investment not only allowed the company to be incorporated, but also gave Huang a 20% ownership stake in Nvidia. But this was only the beginning of their journey. The next big challenge was finding the funds to bring their ambitious vision to life. Convincing investors was not easy. Venture capitalists were more interested in founders with a proven track record and a strong vision than in detailed business plans. Despite these hurdles, Nvidia eventually attracted the attention of Sequoia Capital and Sutter Hill Ventures, securing $20 million in funding. Let's take a step back and see how Nvidia first started out. Betting big on Nvidia. For many, this amount of funding might seem extraordinary for a startup, but Huang's previous connection with LSI Logic played a crucial role. He used his connection with the CEO of LSI Logic to set up a meeting with Sequoia Capital, a venture firm that had previously invested in LSI Logic. Initially, there was some skepticism, but Sequoia Capital eventually took a chance on Nvidia, seeing the potential in the growing graphics card industry. Their initial investment of $2 million was followed by another $18 million, setting Nvidia on a path to success. But this wasn't the most difficult part. At the time, investing in Nvidia was a risky move. There were 89 other companies with similar goals, but only AMD and Nvidia managed to survive the competition. When Nvidia went public in 1999, its value skyrocketed to $600 million, making the initial investment worth it many times over. But let's not jump too far ahead. At that point in the story, Nvidia was still a small team of engineers working hard to bring their first product to market. With the funding secured, it took them 2 years to build a team and develop their first product, the NV1. Officially launched in 1995, the NV1 was Nvidia's first step into the market. During the development of the NV1, Nvidia made a deal with Sega to produce chips for their gaming consoles. These chips were designed for popular games like Virtua Fighter and Daytona. Interestingly, the NV1 chips were also compatible with PCs, allowing players to enjoy Sega Saturn games directly on their computers, a revolutionary idea at the time. Nvidia made a bold choice in how they designed the MV1 chips, opting for an image rendering architecture based on quadrilaterals rather than the more common triangles. But this wasn't just a technical decision. It had real-world consequences. The idea behind using quadrilaterals was to speed up rendering by reducing the load on the CPU. In theory, this approach would require fewer polygons and better represent rounded objects, giving designers more flexibility. However, as technology advanced and memory capabilities improved, this approach became less practical and even posed compatibility issues since it didn't support OpenGL. Are we approaching a point where AI can outperform human intelligence across all domains? Let me know your thoughts in the comments, and don't forget to like and subscribe for more.